All right, now we're going to look at section 7.2 when we're estimating parameters and determining sample sizes. And here we're going to look at estimating a population mean. Now, there are two unbiased estimators that we're going to talk about, proportion and mean. We're going to construct confidence intervals on those. If we were going to do a confidence interval on the variance, that'd be fine, but that's actually in Math 150. Stats for life sciences, and that's beyond the scope of this course. It works the same way as we did before, except that you're using your sample mean, which is x bar, to make a inference about the corresponding population mean mu. Again, very early on in this class, we talked about we're using smaller samples to make estimates about the population. And here in this section, we're trying to figure out exactly how well we're actually making that happen. So we have this point estimate, which is our sample mean. And that's the point that we're going to start off, and we're going to say, well, that's going to point to the population. And then we're going to kind of create a confidence interval around it. And we're going to be using distribution in order to make that happen. Now, the deal is, and here's a summary of the variables that we're going to be using again. We're going to be using the sample standard deviation. Now, that is a biased estimator. And so a long time ago, there was a gentleman by the name of William Gossett, and he worked for the Guinness Brewing Company in Dublin, Ireland, and he was in charge of quality control. When you buy beer, you want to make sure that the beer that you're getting is similar to the same brand that you're getting anywhere else. And they wanted to reduce the amount of variability that you got. So every day they would conduct taste tests on their beer to see what the quality was, weight, color, taste, those kinds of things. But the issue that we had was that, for obvious reasons, it had to be small samples. And he found that the normal distribution just didn't cut it for sampling in these small samples. So what he did was that he actually created a different distribution called the student T distribution. Now, he had to call it the student T distribution because he wasn't allowed to publish his results. Guinness actually said, you're not allowed to publish your results. On the normal distribution, but what he did was that he augmented the look of the distribution based upon the sample size. Now, some requirements before we actually get into this is that the sample that you're doing has to be a simple random sample. Now, either both of these conditions are satisfied. The population has to be normally distributed, or you have to have an N that's greater than 30. Now, this is the same thing that we did when we looked at the central limit theorem. You have to have either one of these conditions to be satisfied. So now here we look at, and this is how we construct a margin of error. We have this T alpha over 2. So we're not using z-scores anymore. We're using something called t-scores. And then we also have this concept called the degrees of freedom. Now for us, our degrees of freedom are going to be one less than the size of our sample. So here's a slide that comes up with that. Now to find out the actual value of our t, we can use this formula here. But again, we're going to make StatCrunch do the heavy lifting for us. Now, the distribution starts and looks like the standard normal distribution, but based upon the size of your sample, it will change the look of how that curve is. But the way that we actually construct our confidence intervals are going to be exactly the same that we did when we did a proportion. We're going to start off where we're going to have our sample mean, and then we're going to add and subtract our margin of error, where we're going to try to actually target the actual population mean. So let's go ahead and look at some of your homework problems on that. So let's go to section 7.2. Okay, so here's an example where we have our summary statistics for randomly selected weights of newborn girls. We have an N of 181. We have a samples mean of 26.5, and we have 7.1. And then we're going to construct a confidence interval estimate on the mean, and we're going to use a 98% confidence interval. So we're going to use StatCrunch. You know this word. It says hip. Hip is my name. And we're going to use T-stats this time. One sample with summary. Our sample mean is given as 26.5. Our sample standard deviation is given as 7.1. And our sample size is given as 181. Again, these values come right from our problem that we have here. Confidence interval, we're going to click and we're going to do a 98% confidence interval here. So I'm going to change that to 0.98. I'm going to go ahead and click compute, and I'm going to get my answer. I'm going to have my lower limit and I'm going to have my upper limit. So I'm going to do 25.3 and 27.7. And that's pretty much it for all of these. The results between the two confidence intervals are very different. So here we want to compare what we had before. We had 25.3 to 27.7, and then we had 25.3 to 28.5 with only 18 sample values. I would say that those are actually pretty close. And are the results for two confidence intervals very different? No, because the confidence interval limits are similar. Okay. Let's do one more example with actual sample data that we have. Here we have the study of speed dating. Male subjects were asked to rate the attractiveness of their female dates. And a sample of the list. 1 is not attractive, 10 is extremely attractive. Construct a confidence interval using a 90% confidence level. What do the results tell about the mean attractive ratings about the population of all adult females? All right, so I'm going to click to copy this table, and I'm going to open it up in StatCrunch. And so what that's going to do is it's going to open up StatCrunch with my data that's already there. And then I want to do a 90% confidence level estimate of this. The nice thing about StatCrunch is that it will figure out your sample size, your sample mean, and also your sample standard deviation based upon the numbers that you give it. So I'm going to go to T-stats. I'm going to select one sample, and I'm going to do with summary here. With data, because there's my data. I'm going to double click ratings, and then I'm going to select my confidence level of 90%. And that's it. I'm not going to check anything else. And I'm going to go ahead and click compute, and I'm going to get my confidence level. Now here it gives me my sample mean. That's my X bar. That is my point estimate. My standard error here is S divided by the square root of N. And then I also have my lower limit and I have my upper limit. Let's see, it's going to be 4.98. That's going to do a 5.0. And that's going to go to 7.7. Okay. So now you can, what does the confidence interval tell about the population of adult females? We are 90% confident that the adult. So this is where you kind of have to make a judgment call. We have a small sample here, speed dating. We're not talking about a full population. So really, these results tell us nothing about the population, okay? So these interpretation questions, some of them can be a little bit tricky, but remember that if you have really, really small sample sizes, there's not a lot that they're going to say about the adult females, but also we have to understand what we're talking about here. We're talking about using speed dating to represent the entire population of adult females, okay? So we can see that the sample size, the characteristics of that sample are not necessarily the same as the characteristics of the population. All right, and that's going to conclude Chapter 7. Again, if you have any questions, you can always use the Ask My Instructor feature here. That will send me an email that will help you out. You also have videos in your textbook and help me solve this and view an example for most of these questions. And a lot of them have data that we actually pull down, which is nice because if you're actually doing any data analysis going forward, you're going to have data that you want to analyze here. And StatCrunch makes it real nice because you're allowed to copy the table, open it up in StatCrunch, and then you can perform your data analysis. All right, and then the last thing here, for all of our confidence interval stuff that we're having, we're only using proportion stats and t-stats. Those are the only things that we're using to actually make that happen, okay? All right, that's it. Good luck on your homework, and I'll see you soon.